Hey guys, welcome to this new video. Focus on the first order linear differential equation. In the general form of the first order differential equation is given by this equation, and if we divide everything by the coefficient a1, then we obtain this form. Okay, we can just rearrange into this second form. So this equation then can be solved by multiplying through the integrating factor. So, and the integrating factor here is, let's take this, I of x is our integrating factor. Is defined as exponential the integral of what we have here, the coefficient carried by y. This is p of x dx. So if we derive this integrating factor, we have the following. The derivation I prime of x will be p of x times I of x. Okay, this is the first derivative of this. Now, as we say that to solve this equation, we can multiply this through by the integrating factor. So let's multiply this equation and see. Let's call this equation 1 and 2. 1 and 2. Now we multiply equation 2 by the integrating factor. We have the integrating factor multiply dy over dx plus p of x times the integrating factor, okay, is equal the integrating factor times q of x. At this stage, we want to know what's happening here. Remember that this is a product rule. This is obtained from the product rule. Remember that for the product rule, if we have f times the function g, we want to find a derivative. The product rule says that is f times g plus f times g prime. So here we can see that if this is your function f, this is f times g prime. If f is I and then g is y, then this is f times g prime plus g prime times f, okay? So this can be written as the derivative with respect to x of I of x, y. And this is I of x, q of x. Alright, at this stage, we just have to integrate both sides. Integrating both sides, you integrate here. We also integrate here. We add dx here. And this leads us to the following. So this with the integral and the derivative is just the same function, okay? So this is I of x times y is equal the integral I of x q of x dx. Here we can solve for y. Y of x is 1 over I of x, the integral of I of x q of x dx. If this is clear, now let's take an example. Let's look at this example. So we want to solve this first order differential equation subject to y of 1 equal 0. So let's use the integrating factor. I of x is e to the power the integral of p. P here is minus 4 over x dx. So we continue. This is e to the power minus 4, the integral of dx over x. And this is minus 4 logarithm of x. So this is also e to the power logarithm of 1 over x to the power 4. So this is 1 over x to the power 4. Alright, this is the integrating factor we obtain. Let's then multiply the original equation, this equation, by the integrating factor, okay? By 1 over x to the power 4. This is 1 over x to the power 4 times y prime minus 4 over x times 1 over x to the power 4 times y is equal to 1 over x to the power 4 times x to the power 5 times e to the power x. Okay, we can simplify this in this way. This is 1 over x to the power 4 times y prime minus 4 over x to the power 5 is equal x times e to the power x. So, using the products rule, we see that this part is the derivative with respect to x of I, this 4 times y is equal x times e to the power x. At this stage, let's integrate and see. If we integrate both sides, we have d over dx of 1 over x to the power 4 times y is equal to the integral of x times e to the power x dx. Right. Here, this is just 1 over x to the power 4 times y is equal this integral. So if you use the integration by part here, using the integration by part lead to x times e to the power x minus e to the power x plus c. So we use integration by part here. Let's put this integration by part. Okay. Then if we rearrange this, we multiply this equation through by x to the power 4. Then the final step is x to the power 5 times e to the power x minus x to the power 4 times e to the power x plus c times x to the power 4. And this is the final solution. So this part, this is the particular solution, and this one is the homogeneous solution. This is then the final solution to this example, which is just the sum of the particular solution and the homogeneous solution. Okay, this is all for this video. Thank you. In the next video, I'll introduce the theorem of Wronskian and show you how to use it to solve other type of differential equation. Thank you.